Okay, Kalispera. For respect to our guests, I will do this presentation in English, so please mind the English. For today, I chose a case that actually is a bit old, let's say. It's from, as a concept, it began, let's say, in 2007 in the United States. It's the case of Harley Davidson. And I'm trying to depict, let's say, the whole effect that a digital transformation or a business transformation has on a whole organization. What actually we will see through this specific case is that any transformation process actually does affect people, processes, capital investment, and technology. Okay, so anyone who thinks that he can get away with either one of it, I think he's fooled. Or you cannot be doing a little bit of each one and something more than on the other. It's something that you have, every organization has to consider, let's say, in total. The case of Harley Davidson began practically, the problems started in 2007 with the first recession. I think we might relate to this a bit in certain situations. And that's when everything started to go through a downfall. Practically, the share price started to shrink. Their sales revenues were being reduced. They started laying off people, which is one of, let's say, the easiest or most difficult things to live with, but easiest maybe things to do in order to cut costs. And this was continuing over throughout the next years. So what Harley Davidson actually tried to do is think about, let's say, a new strategy of how to turn this situation around, or practically how they could survive this difficult situation. So they actually said that they will focus along, let's say, 3 strategic, let's say, initiatives. And these were there to address the top line and the bottom line of the company, because they've lost sales and they have to manage the cost. So one of the 2 things that they tried to do is to invest in the brand, make it more known, attract more young people, since the people at that time using Harleys were of a generation that was getting older. They also needed to find additional funding for their financial services in order to help people buy. As you know, back then in the States with the recession, practically it was, every bank was defaulting. It was a bit difficult to get a loan and have people to get loans in order to consume. And what this case is about mostly is focused on their initiative of adjusting the cost structure. And that included a lot of things. Included, let's say, the consolidation of 2-engine transmission plants. It included the consolidation of the paint and frame operations in its assembly facility, and that's the facility that I will be talking about in the next slides. It's the York plant in Pennsylvania where they assemble the bikes. They had to close the distribution facility and basically outsource the distribution of the spare parts and accessories to a third-party logistics provider. And they also, as we can see here, they laid off quite a lot of people. So they practically began by looking at the capital, let's say, investment, of tackling that issue. The specific factory in York, on the left you can see the old situation, on the right you can see the new situation, what happened. Actually they had about 440,000 square meters of factory space, which was reduced to almost, let's say, more than half, almost a third, to 60,000. They had 41 buildings in total in the vicinity, and that has been shrunk down to 2. Employees were also halved, and they had to go into special agreements with the labor because it wasn't viable. So they had to get consent from everyone in order to move forward with this digital transformation. So you can see they kind of restructured the salaried employees and also the hourly and casual employees for the plant. This would allow them to be more flexible, especially when they had new model introductions and where let's say your production starts building up and reaches a peak. That gave them the flexibility in order to have. That gave them the flexibility to have to tackle, let's say, the cost of labor. So apart from the, let's say, the new labor agreements, what they actually did at the end, also in terms of the parts that they had and the plant itself, they decided to focus on what they do best. Initially, the factory was a vertically integrated production facility, meaning that they would produce everything that the motorbike needed. That would be even screws and washers. So they said they would focus purely on the frames, the tank, the fender, and the painting of these, and also the assembly of the bike. So visually, sorry, I have something. Okay. So if we were to take a picture, an air view of the factory, this was the whole factory, the whole of it, all these 41 buildings. So the portion that was taken away was the one under the red layer. And they took the old one, and they actually expanded certain sections of it in order to cater, let's say, for the parts of that factory that were integrated to the new, smaller one. Why was it that big? It was that big because they had 5 different types of motorbikes that they produced, and they had a dedicated assembly line, production line for each bike. So what they did was they consolidated those production lines into one. So it was one production line doing multiple models. And we will see further down how they achieved that flexibility. So this is the view of the plant as it is today. As you can see, the space that they had, they sold it off to consumer company. So I guess that was, they were happy with that. So they focused on that part of the plant. But the challenge was, how can you fit all that plant that was gone into that, let's say, vastly reduced space? So they had to find a more flexible digital supply chain approach in order to cover that. And as I said, they did that by consolidating the assembly line, and they practically created one let's say, production line, which began from the section where they would have the presses and make the fenders and the tanks, the part where the frames of the bikes would be manufactured. Then you would have the paint staging, and before everything was painted, they would attach the vehicle identification number, the unique identification number of each motorcycle on the frame. This could be, let's say, the most important part of the production assembly, because based on the vehicle identification number, they will tie all other parts with the specific motorbike that was being manufactured. Always on the specifications of the customer. Imagine, I think you all know Harley Davidson motorbikes, what they're like. You can actually choose out of 1,250 different variations of it. And that does not include the colors. So the complexity of making a bike is quite big, but they try to include that all in one assembly line. So this is where they actually tied all these parts together, and the whole monitoring of the process and the assembly of the bike was actually followed based on that VIN number throughout the rest of the assembly. So what modifications did that include? They implemented, as I said, a single digital supply chain. They introduced the concept of a flexible production line. So there was one production line that was capable of having different types of motorbikes being channeled through it, and within that production line you had different, what they call work cells, and each work cell actually did a different job on each bike. And depending on the type of bike, the bike that was on what they call an automatic guided vehicle would automatically stop to that work cell for the assembly to be performed on it, based always on the production instructions. So here you can see a view of what the traditional production model was on the left, where actually there was one production line for each bike. Every worker was sitting on a fixed workstation, and these bikes were coming through in 5 different assembly lines. And that on the right is the single production line that would cater for all 5 different types of bikes. This is a complete view of the factory. What needs to be noted is that the whole facility was connected on a wireless network. And when I mean the whole facility, I mean from these automated guided vehicles to the machinery that's been used, even the tools that are used, the wrenches, the torque wrenches that are used, those were also connected to the wireless network. And why was that? Because each workstation had to display on a special screen what were the work instructions that had to be executed by the workers. So every time a guided vehicle with a specific VIN number came through, it would automatically recognize where it should stop, in front of which workers. The workers would actually see on their screen what work instructions need to be done. And in addition to that, the tools would be automatically set by the system to the required torque that is needed for the specific model of the bike. You understand that depending on the model, there are different torque wrench that has to be applied on the assembly. So this is practically, let's say, one of the screens that are at the workstations. The two people on the same workstation, one working on different side of the bike. The system would actually feed each one with the instructions that he has to do. They would give him visual view of what has to be done. And a timer would start ticking and would actually inform him how long he is taking based on the let's say, the default time that needs to be done on the special process. Any part that they would assign on the bike would actually be scanned. And any other problem that might occur, like a small maintenance failure on the production line, they would also do it through this application on a specific touchscreen. So practically what they were trying to achieve, and they achieved it up to a very high degree, was to have a completely paperless factory. So before, where they had instructions being printed out on how they should be assembled, those were always attached to the bike. Now everything is displayed on the screen. The system knows which vehicle is being processed at the moment. And based on all that data, the workers could work more efficiently, and also they could have, let's say, an overall view of what the actual production status was. So here, for example, we can see the lines A, B, C, D, E, T, P, and TR are the different types of bikes. On the right are the number of the work cells that were actually doing work at that time, which were within time, what was the total downtime. On the top, they had other KPIs where they could see how many bikes were manufactured from the total in that day. And they could also show the comparison of the previous shift with the current shift on a specific work cell, how they were doing. So this information was broadcasted throughout the whole factory, and every worker was involved in actually trying to improve the situations. And practically, let's say the floor managers were able to see where possible bottlenecks could appear in the whole production. Another dashboard that the managers would look at is this, where we can see on the different production, let's say, bike types, we can see which VIN numbers are assigned at which work center. And with the green dots, which are some are filled and some are empty, actually indicates if the work that has to be done on assembly work on each bike, on each side of it, has been completed or not. So just by looking at this at once, very briefly, they could actually see work completed or work that has to be still be completed. So basically, what hides behind this is, of course, technology, and that's where we came in, and we actually gave them these dashboards and the vision and the control and the management, all of these, let's say, information towards the shop floor, and also the live feedback from that to our systems, in order to achieve let's say, an optimized synchronization between demand and production. So basically, their goal was to get the sales orders from the dealers, include all these available supplies of raw materials and the requirements that might be happening, align that with the demand plan that they had already done, and try all that information to input into what we call an optimizer and try and schedule it on the best possible way in order to create the absolute production plan in the factory. If we were to see another diagram of what it means or what is the day in the life of an order, a customer order, practically orders that came in, as I said, were highly configurable. So these attributes had to be taken into account in order for the system to assign these orders to a specific customer, but also to check if these type of bikes are already available or are partially available or additional supplies need to be procured or manufactured. However, this whole process is not focused only on this plant. They had to send planning data to the second plant, which was actually producing the motor engines. This plant, as I said, is an assembly plant and a painting plant of the fenders and the tanks. So an important component was the engine. Therefore, all orders and the demand was also sent to the production plant of the motors, which actually had to also plan accordingly in order to effectively supply the assembly plant with the motors. So within the York plant, what they actually did is that all these orders were, let's say, scheduled and managed, where priorities were given, and they're trying to manage the conflicts. The highest, let's say, biggest bottleneck or constraint in production was the painting process. So they had to lock that 6 hours prior to any execution. And finally, the assembly, which actually was the most flexible part of the whole production process. Just to step a bit into our world, into the SAP world, and try and relate, maybe most of you might be able to relate to this. The whole sales order and the production order processing happens and definition happens on an ERP level. So all the bill of materials, all the production steps needed, all the routing that we are talking about is defined within an ERP, which is then pushed down to a manufacturing execution system. This manufacturing execution system actually monitors the whole thing and actually sees what's necessary to be sent further down through a connector to the automation layer, which is basically the machines themselves. So based on the capability of these machines, we can get sensor data back and actually update the rest of the process, either with performance data or with actual information concerning, for example, raw material that is missing or spare parts that are missing or any other inconsistencies that might actually create a problem to the whole production. So to end this case, the actual benefits that they realized was in that specific plant was a reduction of operating costs of over 200 million per year. Achieved throughout, let's say, the lowering of the labor costs and plus the inventories. I forgot to say that they were required to minimize the storage area in the factory. Therefore, they went to specific contracts with specific service level agreements to their suppliers, where they demanded, and suppliers that were from the vicinity, from the same area, and they demanded that they would have delivered the parts that they need, or the screws or whatever, or any other equipment, within 6 hours of when the requirement was broadcasted to them. So their net margin increased by 19%. Of course, you can understand flexibility was highly increased, so they could build any model on the same line. Actually, they could also do fast drills or fast, let's say, tests whenever they wanted a new production process to be implemented or if they wanted a new model to be introduced. And they could actually do it really fast within the existing production line. And of course, the productivity of the employees due to the paperless situation was increased by 2.4%. And the most impressive part was that the scheduling of a production, let's say, of the production of a bike was reduced from 21 days to 6 hours. And actually, Harley Davidson, based on this, offered their customers the possibility, once they purchase a bike, to go to the factory and see their bike actually being manufactured on site in real time. Thank you.
Thank you, Vasilis.